Hello, ladies and gentlemen. Welcome back to Boy Ghost GG. Today we're reacting to another Kurska's video, Quantum Computers Explained. This is something I'm actually very interested in because I know what a quantum computer is. I just don't know what a quantum computer is. You know what I mean? Y'all know what I mean? Y'all understand? I know what a quantum computer is, but I don't know what a quantum computer is. So let's get right into this video.
For most of our history, human technology consisted of our brains, fire, and sharp sticks.
Oh yeah, baby.
While fire and sharp sticks became power plants and nuclear weapons, the biggest upgrade has happened to our brains. Since the 1960s, the power of our brain machines has kept growing exponentially, allowing computers to get smaller and more powerful at the same time.
Yeah, baby.
But this process
A modern
is about
phone
to
is
meet
strong
its
as the
physical
first
limits.
computer, or like stronger than the first
parts
computer
are
that was like
approaching
big
the
as shit.
size of an atom. To understand why this is a problem, we have to clear up some basics. A computer is made up of very simple components doing very simple things.
You know what's wild?
Representing data.
Think of floppy disks. A few decades ago, we used floppy disks to store data. Big ass things. I don't know if you guys have even seen a floppy disk. They're big ass disks they're big ass chips or casings with a disk in it. That's where you store data. And at best, it was a few megabytes at a time. I don't think it ever got up to a gigabyte. It was a few megabytes at a time. And nowadays, you can get a chip this small that you could put into any kind of device, a phone, a Nintendo Switch, or like any kind of device, and it can hold up to like 2 terabytes or something. That's ridiculous. For going from this big, few megabytes of storage, to this small, being like 4 terabytes, 2 terabytes, being 8 terabytes. A chip that's like this long can go in your PS5. It can hold 8 terabytes of data. That's nuts. M.2, right? Or in your PC or whatever. That's crazy.
The means of processing it and control mechanisms. Computer chips contain modules, which contain logic gates, which contain transistors. A transistor is the simplest form of a data processor in computers, basically a switch that can either block or open the way for information coming through.
All right.
This information is made up of bits, which can be set to either 0 or 1. Combinations of several bits are used to represent more complex information. Transistors are combined to create logic gates, which still do very simple stuff. For example, an AND gate sends an output of 1 if all of its inputs are 1, and an output of 0 otherwise. Combinations of logic gates finally form meaningful modules, say for adding 2 numbers. Once you can add, you can also multiply, and
I've done
once
very
you can
little
multiply,
computer science
you
in
can
my day,
basically
just
do
in high
anything.
school.
Since all basic operations are literally simpler than first-grade math, you can imagine a computer as a group of 7-year-olds answering really basic math questions. A large enough bunch of them could compute anything from astrophysics to Zelda. However, with parts getting tinier and tinier, quantum physics are making things tricky. In a nutshell, a transistor is just an electric switch. Electricity is electrons moving from one place to another, so a switch is a passage that can block electrons from moving in one direction. Today, a typical scale for transistors is 40 nanometers, which is about 8 times less than the HIV virus's diameter and 500 times smaller than a red blood cell's.
Wow.
As transistors are shrinking to the size of only a few atoms, electrons may just transfer themselves to the other side of a blocked passage via a process called quantum tunneling. In the quantum realm, physics works quite differently from the predictable ways we're used to, and traditional computers just stop making sense. We are approaching a real physical barrier for our technological progress. To solve this problem, scientists are trying to use these unusual quantum properties to their advantage by building quantum computers. In normal computers, bits are the smallest units of information. Quantum computers use qubits, which can also be set to one of 2 values. A qubit can be any 2-level quantum system, such as a spin in a magnetic field or a single photon. 0 and 1 are this system's possible states, like the photon's horizontal or vertical polarization. In the quantum world, the qubit doesn't have to be in just one of those, it can be in any proportions of both states at once. This is called superposition. But as soon as you test its value, say by sending the photon through a filter, it has to decide to be either vertically or horizontally polarized.
All right.
So as long as it's unobserved, the qubit is in a superposition of probabilities for 0 and 1, and you can't predict which it will be. But the instant you measure it, it collapses into one of the definite states. Superposition is a game changer. 4 classical bits can be in one of 2 to the power of 4 different configurations at a time. That's 16 possible combinations, out of which you can use just one. 4 qubits in superposition, however, can be in all of those 16 combinations at once. This number grows exponentially with each extra qubit. 20 of them can already store 1,000,000 values in parallel.
Wow.
A really weird and unintuitive property qubits can have is entanglement, a close connection that makes each of the qubits react to a change in the other's state instantaneously, no matter how far they are apart. This means that when measuring just one entangled qubit, you can directly deduce properties of its partners without having to look. Qubit manipulation is a mind-bender as well. A normal logic gate gets a simple set of inputs and produces one definite output. A quantum gate manipulates an input of superpositions, rotates probabilities, and produces another superposition as its output. So a quantum computer sets up some qubits, applies quantum gates to entangle them and manipulate probabilities, and finally measures the outcome, collapsing superpositions to an actual sequence of zeros and ones. What this means is that you get the entire lot of calculations that are possible with your setup all done at the same time. Ultimately, you can only measure one of the results, and it will only probably be the one you want, so you may have to double-check and try again. But by cleverly exploiting superposition and entanglement, this can be exponentially more efficient than would ever be possible on a normal computer.
Okay, so you can do multiples at the same time than the computer going one by one.
Replace our home computers, in some areas they are vastly superior. One of them is database searching. To find something in a database, a normal computer may have to test every single one of its entries. Quantum algorithms need only the square root of that time, which for large databases is a huge difference. The most famous use of quantum computers is ruining IT security. Right now, your browsing, email, and banking data is being kept secure by an encryption system in which you give everyone a public key to encode messages only you can decode. The problem is that this public key can actually be used to calculate your secret private key. Luckily, doing the necessary math on any normal computer would literally take years of trial and error. But a quantum computer with exponential speedup could do it in a breeze. Another really exciting new use is simulations. Simulations of the quantum world are very intense on resources, and even for bigger structures, such as molecules, they often lack accuracy. So why not simulate quantum physics with actual quantum physics? Quantum simulations could provide new insights on proteins that might revolutionize medicine. Right now, we don't know if quantum computers will be just a very specialized tool or a big revolution for humanity. We have no idea where the limits of technology are, and there's only one way to find out. This video is supported by the Australian Academy of Science, which promotes and supports excellence in science. Learn more about this topic and others like it at nova.org.
Well, there we have it. That's quantum computers. I still don't 100% understand quantum computers other than the fact that they make everything faster. They make everything that a computer can do much more faster, but it requires a lot more energy, it has to be a lot more powerful, requires a lot more technical components, but they seem cool. Right now, all he really said about quantum computers is you can search for stuff faster. And instead of being a one by one that a computer goes by, the quantum computer can do multiple at the same time. That's essentially what I got out of it. Is that an in-depth understanding of quantum computers is very top level, but it's a 7-minute video. I'm not expecting you to go deep level like what are quantum computers used for right now in the world. I'm sure like NASA uses quantum computers or some shit, and like these big companies. Maybe there's a video like that somewhere out there that I can watch. But yeah, I just wanted to check out this quantum computer video because I've heard of quantum computers. I've done quantum stuff in some of my university science classes. I can't remember which one. I think it was chemistry. Something about some chemistry quantum stuff. It's nothing crazy, but quantum is a word that's used a lot in sci-fi. And to learn something that is quantum, like a quantum computer, it's just interesting, you know? I love sci-fi. I just want to learn something about quantum computers. So yeah, this is what this reaction was all about, really. And yeah, hope you guys enjoyed. Hit the like button, subscribe, and hit the notification bell to keep updated with more reactions like this. Peace out.